Welcome to Programming a God. Today we will be solving the metal harvest problem from Google Kickstart Round F. According to the problem statement, we have to harvest metal using robots. The metal can be harvested only within the n harvesting intervals that are provided to us. Only one robot can be deployed at a time, and it can work for at most k hours. Each harvesting interval has a starting and an ending time. We need to find the number of robots that need to be deployed to harvest metal at all possible harvesting time. The input is as mentioned. Let's look at an example. The value of n is 3 and k is 5. The three harvesting intervals are as shown. Let's look at how the robot deployment will work. The first robot will be deployed at 1 and it will work till 1 plus 5, that is till 6. It will cover the first interval. The second robot will be deployed at the starting of the second interval, that is at 8, and it will work till 8 plus 5, that is 13. It covers both the second and the third interval. So the total number of robots to be deployed are 2, and that's our answer. To solve this problem, we will first discuss the necessary things. For every interval we need to check if there is a robot that is currently active. If no robot is active, then we start deploying robots from the starting of that interval. If a robot is active, then we start deploying from the ending time of the current robot. For every interval we need to keep deploying robots till the ending time of the final robot becomes greater than or equal to the ending time of that harvest. The intervals may not be in ascending order, so we need to sort them first. We will store the input in a vector as pair of integers and then sort them. We will use a variable current to store the ending time of the current robot. Initially it is set to 0. Let's look at the algorithm based on this. First step is to store the input and sort it out. So run a for loop for n times. Each time push the interval into the vector. Now sort the vector. Now we need to find the total number of robots needed. Initially current is set to 0 and number of robots is also 0. Now for every interval we check where to start our deployment. If current is greater than the start of the interval, means a robot is already working. So we will start from the ending time of this robot, which is current itself. If no robot is active, then current will be start. Now use a while loop to keep deploying till current becomes greater or equal to end. Every time increment robots by 1 and increase the value of current by k, which is the ending time of this robot. Finally print the value of robots. Next we have provided the C++ code for this problem. Please subscribe to support the channel.